All right, so domain, that the domain is talking about all the possible input values or x values. These are input values. So in real life situation, if we have a function that is referring to the price of a taxi fare, that would be the output, would be the price. The input would be the distance that they travel. And in a taxi, there are limitations. So you can't go any less than 0 kilometers, right? So that's a really, and then for price, that depends on what the function is. So most taxi companies will start with a starting cost and then charge you so much per kilometer. So I guess it would be the starting cost plus, depending on how many kilometers you go, that would be the range for the price. Okay, so these are the y values, or f of x. Okay, this is the output. All right, so also the input, those are horizontal values because we know this is our x-axis, and the output are our y values. Those are vertical values. Okay, so when we are given a graph, we can really just look at the horizontal and vertical. We don't need to really look at every individual piece. Okay, so let's start with the domain. Okay, so the domain here, I'll put that in red. Those are all the horizontal values. So this arrow means it's going to keep going forever. So as it keeps going, it's going to the left. So it's going to keep going forever that way, right? And then we can see all these values here are included, and it keeps going that way forever too. So this represents all the real numbers. So this is all real numbers. That's the symbol for it. You could just say all. You could just write all real numbers. If we use set builder notation, we'd put these brackets in here, which means the set includes. So x is such that x is any real number. Okay. There are other ways to show this, but I will accept anything that is, even in words. If you said it could be any real number, that's fine too. Okay. I think my dog agrees with me. He definitely agreed on that one. Okay. Output. Look down here. So you can see that you've got this value here right at the x-axis here, but there's nothing below it. There's no negatives. And then you can see it's just going to keep going forever there, right? It goes forever. So we can say y, or f of x, is greater than or equal to 0. Okay, so set builder notation, y is such that y is greater than or equal to 0. Right? Even if you said it in words, I would accept that. Okay. And you're going to be matching graphs because it's one of those kind of questions. It's not, you're not actually going to have to write it. Okay, so let's do the same thing over here. We're looking for all the horizontal values. Look at, this is the last one right here. And then it goes all the way, and then boom, stops right here, right? So it looks like it's going from -5 to 5. Okay, so x is going from -5 to 5. And it's including +5, right? But not the -5. So it looks like that. If you write in set builder notation, x is such that x is greater than -5, less than or equal to 5. Okay? Take a look at the range. Those are all the possible vertical values. So we got nothing down here. Our lowest value is here. It's not included on this part, but it is here. On this one here. This one right here is included. And then it goes up, and it goes up to, and it concludes this value here at 2. Okay, that's it. That's all we have. So it's another one where it's in between 2. So we got 2. And what's that? That's actually -2. And it includes both of those values actually. So if we put it in set builder notation, which again we don't have to, we would say it's between -2 and 2. If you're not sure, just say It's in between and including -2 and 2. You could explain that. You're going to have to be matching for the assessment on this part anyway. Hope that helps.